Guten Tag, ich begrüße Sie alle ganz herzlich zu unserer Online-Vorlesung Distributed Systems and Blockchain. My name is Thomas Bocek, and today I'm going to talk with Jani Helin, who is the CTO of Moflix. Moflix are operating with Sunrise and the Swipe platform. I can briefly show you the website here. This is the following website. Probably some of you already know that. So it costs 20 Swiss francs per month, 150 daily, and they have a very nice business case because you download the app, you don't need to go into the store, and you can do everything from the app. So the onboarding is fully digital, and I think this is quite awesome, and I think this is a really good business case. So, Jani, thanks for taking the time. Can you quickly introduce yourself?
Sure. So my name is Jani Helin. I'm leading the engineering team here at Moflix at our office in Finland. And I have like 20 years of experience on the field. I have been with Moflix like 1.5 years. So all the time we have been existing because we are a new startup still. And for most of my career, I have been working as a software architect or a DevOps consultant. And I have also done plenty of software development. I also, for example, wrote software for the Nokia phones from the late 90s onwards, as long as they kept making those.
Which language do you use for that, for writing that?
The phone software, that was C++ with this Symbian OS.
Okay. So not something like Erlang or something kind of weird programming language.
No, it was very old school, and I think it was because of the tight hardware requirements at the time when those operating systems like originated.
Okay. And can you tell us something about your current tech stack? So what are you currently working with? So what are your main tools?
Yes, so here at Moflix, we make the mobile applications where, as you mentioned, a person can fully onboard, identify himself, and make an ID check, order a SIM card or use eSIM and get a subscription and so on. The applications are cross-platform applications that we make with the React Native. So the code is TypeScript or JavaScript at that level, and plenty of those JavaScript frameworks, of course. Some parts of the front ends have been written with native implementation, depending on which SDKs we need to use for the integrations. For the backend, we use heavily Amazon Web Services. We use serverless stuff like Lambda functions for the orchestration. So that is the most important part. We have API gateway, which controls the access. The authentication is in AWS Cognito, and the databases are the Dynamo database for the document-oriented stuff, and then Amazon RDS for the SQL databases. And we also have a billing system which is running under Docker in the AWS Fargate.
Okay, so that's basically a serverless architecture. That's quite interesting. So not only the business case is quite revolutionary. I quickly also show the Swipe website also for the students. So this is the front end that you see done with React. Here you see that it's quite easy. And with eSIM, it's you're ready to go in 5 minutes. You have your mobile subscription, and I think this is quite revolutionary. And also on the technical side with the serverless, it's also very interesting. And one thing I wonder with the serverless, so how do you program the backend? So currently we are in another project where we have Spring Boot, we have an IDE, we have IntelliJ, and how do you work with the backend with serverless? Is it just you have your browser and that's it, or how is the developer flow there?
Well, browser you mainly need for accessing Stack Overflow if you don't know how to do something. I would say otherwise the development, because a serverless solution is not really a serverless in the end. There is a server somewhere, you just don't see it. And if you are a backend developer here at Moflix, I would say you will be running plenty of servers in your own laptop. So for example, for these Lambda functions, Amazon they have this serverless application model, which has a command line interface, and basically you just type npm run on your local laptop, and it lifts you all the Lambda functions as local servers, so to say. I guess it's based on Docker underneath, but you kind of don't see it. And once you have done that, you can invoke those local Lambdas with any way you prefer, like Postman, curl, or Swagger, or whatever. And that is actually pretty good environment for testing. You can test each Lambda separately and see what is the output and so on. And I say it works pretty well. But that is not all. So if you want something more, let's say you want to test Dynamo database and some other AWS services that are not included in this standard solution, there's a thing called local stack. You can find it in a GitHub, and it's like local simulation of most of the AWS stuff. I can provide you a link for the show notes if you want.
Yeah, I already have the site open, so it's GitHub local stack, fully functional.
Yeah, if it's a page that lists plenty of AWS services that they support,
oh,
so
nice.
That's good.
Oh yeah,
and
that's a lot. Yeah,
yeah.
EC2, DynamoDB, CloudWatch, basically everything. Yeah, that's cool.
Yes,
Okay.
so that we have used, for example, for some developing our performance test cases and stuff, like if you want to generate, let's say, millions of entries in Dynamo database, but you don't want to mess up the common development environment, then this local stack is actually a pretty good option.
Oh, cool. So even your serverless, you still run your stuff locally?
Yes, then it's of course a question like how local it is. Like you can say it's on your laptop, which is fine for the Lambda functions for the Dynamo. But in our architecture, we have plenty of integrations. We try to integrate to ready-made services for the user identification, for the payments, for customer care, for marketing purposes, and so on. And some of these integrations might still be like remote, so to say. So even if I have all the backend on my laptop, it might connect to the sandbox versions of these environments. So basically for every external dependency, we have a sandbox environment, and we use it from our own development environment, but also from the local environment.
Okay.
I have been dreaming of like a truly local environment that I could use in an aeroplane, but the guys actually said to me that nowadays you can have a wireless connection in an aeroplane, so maybe better than mocking all the dependencies.
I see. Okay. You also mentioned if you have a million records in a database. So what happens if suddenly your service goes viral and everybody accesses the services? How do you scale this?
Yeah, that's actually a very good question, and this we are of course thinking a lot. So we of course try to use services that are really scalable, like this Dynamo database. I was, for example, thinking that, okay, does it really scale? And I asked our test responsible to generate this local version. So he made a Dynamo database with this local stack and put there like 6 million users on his own laptop, and there was no issues.
Okay.
And that was just a laptop, not AWS data center. So Dynamo database, for example, we see no problem, but of course in practice you can have something, and we are monitoring our production backend really closely. We have alarms and metrics on the Lambda function execution times. We are following the trends if they are starting to go up. We are also monitoring the RDS service, and for example, we noticed that it started to generate a bit of a load, not much, but a bit more than it should.
Mm-hmm.
And actually, we could improve the database indexing, so it went pretty much flat again. And we also use some throttling limits on the API gateway, because you can set kind of limits that, okay, that for example protects a bit against these kind of denial of service attacks and so on. Because if you normally have, let's say, 1,000 users per hour or minute, there's no reason to allow like 10 million, because that won't happen in a second. So
Mm-hmm.
then the API gateway protects you from this kind of mass attacks.
Okay, okay, that's interesting. And so, so if you do front end development and you connect to your server, so do the front end guys have also kind of a mocked backend, or is it also in the cloud? So how does it work with the development with front end and backend?
Yes, so there is actually a possibility to use the fully local backend for the mobile development, but
Mm-hmm.
we were actually discussing this with the front-end developers this morning, and in reality, it's quite independent.
Okay.
So most of the application development is the UIs and the layout and so on. And the main point is agreeing the interface to the backend. And for that, we use Swagger definitions.
Mm-hmm.
So then we have a well-defined API, and then the front-end developers know how they should access the backend. And we also try to keep our development environment in a good shape. So we have this serverless backend in 3 flavors. There's a development, staging, and production.
Mm-hmm.
And the development we treat with quite much respect, because it's being used by the front-end developers, backend developers, test automation, and so on. Sometimes even our customers, if we do some exploratory testing or want to show design of the new features. So we try to keep it usable at all times, and most of the times the front-end developers are using the development environment.
Okay, okay. You also mentioned testing. So how do you automate the testing? So you just spin up some servers, do the testing, and how do you do front-end testing? Do you just test the backend, or how is testing done?
Yeah, that's a great question. So we have many flavors of. If we start from the easiest, we of course have some unit test cases where that is applicable if we have enough logic to test. And one nice example is maybe getting some data structures from production and then using those at the unit test cases to make sure that data parsing or something is okay. But maybe the bigger parts, so for the front end, we have UI automation tools for the mobiles, especially for Android. And we use our tool Robot Framework, which is an open source tool for automated acceptance testing. And it's very easy to make plugins for this Robot Framework. So we have a plugin for Android and also plugins for backend. So we actually can make full onboarding, SIM orders, everything with this Robot Framework on the front end, and in the same test case, control the backend and the building system if needed, or check things, do stuff like sign up and then verify the email address directly in the backend and so on. So we have these test cases for the front end. We also use same tool for writing this kind of a REST API driven test cases. So if a developer normally uses Postman to check something, does some Lambda work, we try to put the common scenarios into Robot Framework test cases, and then we can run those as a regression suite. And this Robot Framework has a few good qualities. So the test cases are like human readable, and it integrates well to the like DevOps tools. So you can run it with your GitHub Actions or Jenkins or whatever. So you can really have it in full automation. So we actually run the unit tests, backend tests, and client tests based on Git commits in the GitHub. So it's fully automated.
Okay, that's nice. That's nice. You mentioned quite a few Amazon services. So you are quite heavily using these services, these Amazon services. Is there a way that you can, for example, go tomorrow to the office and say, okay, now we switch to Azure, or now we switch to Google Cloud, or so would it be easy? Would this require lots of work, or?
That is a great question. So I would say that these Lambda functions, basically they are just small programs written in Node.js, for example. So of course you could run those elsewhere. That's not really a problem. The Dynamo database you could replace with Mongo database or something, and the RDS is like just an SQL database. So and then we have this building into Docker, so that also could be run in Kubernetes or anywhere. But then we have some other things underneath. For example, we are using this AWS CloudWatch for the logs, and also for plenty of metrics and alarms. There's, for example, direct connection from our Grafana tool, which is this kind of a real-time dashboard, to the CloudWatch. So we, for example, can see all the Lambda functions at once, how often they are invoked, is there a delay, are there errors, and so on. We have a really great view. So if we would completely switch the platform, then we would also need to change these tools, as well as the deployment part. So currently, if we make a Git commit on the backend, there's an automated deployment with the AWS code build and some Terraform pipelines so that it goes to the development environment automatically. Also, these parts would need to be changed. But I think for the future, this is one topic for us. And one reason is that they still don't have a AWS data center in every country on the planet. So there's places where there's maybe some other data center, and some places where there's like no data centers at all. And one major challenge is how to handle these cases.
Yeah, we also had in our current project, we also evaluated Azure, Google Cloud, and also AWS. And the only not in Switzerland was AWS. So Azure has the data centers in Switzerland. Google Cloud has the data centers in Switzerland. But Amazon, you had to go to Frankfurt. True.
Yeah.
True. Okay, interesting. So I just showed you showed the website with the swipe app, so everything looks quite nice. Do you have something in mind which you could improve technically? Do you see somewhere a kind of improvement in terms of UX, or in terms of, I don't know, some services that could improve, or do you see anything that you could make better?
Yeah, that is also a great question. So let's say that overall we are quite happy with the technology stack, our automated deployments, monitoring everything. This is running pretty smoothly, so we don't have any big issues, which is great. But in the Lambda functions, there's a few things. Like one thing is that if you use API gateway with a Lambda function, it cannot take more than 29 seconds for the Lambda to execute, or otherwise the API gateway will fail your request. And the interesting thing is that the Lambda function will keep running. So you maybe don't even realize that what happened. Like the API gateway request for the client fails, but the Lambda still keeps running. So anything that the client calls and is like normally returning directly, you need to do pretty fast. Even in the worst cases, when they have a big amount of data, plenty of payment history or something, it still needs to complete in 29 seconds, or otherwise it won't work.
Okay, interesting.
And also Lambda functions themselves, they have a 15 minutes hard time limit, so you cannot run a Lambda longer than that. For the most stuff, we have much less. So we have maybe 40 seconds, couple of minutes or something, even for the like background functions, because then, as we discussed the scalability, if something starts to go slow, then we have a bit of time to increase while we do some refactoring or optimization. But if we would keep the limit at 15 minutes, it would be really then we would have no option to increase it anymore. So basically what we need to do is that for these short operations, like let's say there's an ID check that can take 5 minutes, we need to pull it from the client that, okay, has it completed already, and handle it on the background. And if there's like a really big batch processing, like we need to export some stuff for some legacy system, then we might need to do it in many parts because it might not complete in the 15 minutes if we have a huge amount of data.
Okay.
And also one thing maybe about these Lambda functions, like some kind of practical tip that if you have errors or timeouts or anything, and if you are thinking, should I do like a try catch, or should I just let the Lambda fail? In my opinion, it's better to let the Lambda fail. So let it throw the exception and just like a crash, because then you can see it in monitoring, because the CloudWatch automatically reports any Lambda that failed. But if you handle the exception, then you don't see it. And also, if you are using webhooks, the most webhook services, if you fail, they call you again. So you get like a second opportunity. But if you don't throw an error, then that doesn't happen. And even these like cron-based functions, so you can, in the API gateway, you can make timing that, okay, please run this Lambda 5 a.m. in the morning to handle some exports or whatever. If that Lambda fails, also this API gateway cron timing will call you again a couple of times, but only if you fail it. So this kind of straightforward error handling is better at Lambda functions.
Okay, so fail instead of handle it yourself.
Yeah, I mean, of course, if you can fully handle it, that's good. But if you didn't finish the job, then it's better to throw the exception and let it be called again.
Okay, that's interesting advice, yeah. So one last question. Question about the future. So how will the future look like? More serverless, less serverless? Do we have more infrastructure as a service, or even bare metal? So where do you see the trend is going?
Yeah, I wish I knew, but some thoughts. Well, here at Moflix, we will keep using this serverless backend. It has worked really well for us. I think we will continue using these AWS services. One thing, when you asked about the scaling, like one thing I didn't mention is the cost optimization. So if you get a huge amount of more users, it might mean that your tech stack is performing well, but you need to pay a lot more. For example, managed databases and many other managed services, they are much more expensive than a virtual machine. So even though at this moment we don't have any virtual machines at Moflix for the production use, we just have some Dockerized stuff, but for the expenses, from the expenses point of view, it might make a sense to move some stuff from managed services to virtual machines. So in a way, go back in history to save money. This might make sense in some cases. Then these kind of multi-tenancy things, like how to serve totally different customers, for example, different operators using potentially the same backend, or lifting a copy as easy, as cheap as possible. This is big thing for us. And if, for example, AWS adds any new things related to this, we will keep a close eye on that. We already discussed these places with no data centers. There's things like AWS Outpost that basically lets you establish like a small local data center somewhere. That's hugely interesting. It's quite high cost, but for big customers, it might be feasible. So might be one option for expansion.
Interesting. I didn't know about that. Yeah, I just opened the website AWS Outpost. So run AWS infrastructure on service on premise. Okay, cool.
It's really expensive and heavy, but it might be for carrier grade stuff. It might be an option in some cases.
Yeah,
and for some other trends, I think this one question is, where are the servers? Are they serverless? Is it bare metal and so on? But I think even more interesting is the data discussion. Where is the data hosted? who is responsible. For the machine learning and stuff, you need as plenty of data as possible. But in Europe, for the GDPR reasons and so on, you should have as few data as possible. You would not like to own any data. So who is going to handle the data in the end, and how you can do it in compliance with all the changing regulations? That's really a big question. Yeah, and few other trends, the connectivity, like 5G is coming. SpaceX is making these Starlink satellites to provide coverage everywhere on the planet. And then I noticed that these Apple AirTags use like a crowdsourcing. So you can find your tag because somebody else's iPhone is on the range. So it's like taking this distribution into next level, that you don't have any servers, but you might have a user with a phone. So that's actually, I like it from technical point of view. And finally, as a final trend, I think these blockchain things are interesting. So of course, these Bitcoin and Ethereum and so on, and the fact that so much of the data processing power is used for mining these Bitcoins and stuff. And it has like also practical effects, because, for example, my staff members would like to buy new gaming PCs, but they cannot get the display cards because they are all being used for these, these purposes. And how about the electricity consumption and so on? So will it be a big question in the future, that if you can say that, okay, our solution uses the least amount of electricity, maybe this is good, no matter what the solution is.
Yeah. You also have an app for that, right? So you did this token app that you provide on Android and iOS, that people can pay in or burn the tokens, also with this digital onboarding. So you're also a bit in the blockchain area.
Yeah, that is a good point. Yes, so we have an application for that. And if we talk about the architecture, it's basically using the same architecture as we are using for the Swipe. So we have cross-platform mobile applications, we have Lambda functions, Dynamo database, API gateway. It's just that the connections are a bit different. So we are not connecting to any operator network, but we are connecting to Ethereum and so on. But it kind of proves that this architecture is really good and can be used for many purposes.
Okay, then thank you very much. Thanks for taking the time. I think you have given us some really interesting insights. I think the tech stack is quite awesome, and you also have an awesome business case. And yeah, thanks a lot.
Yeah, thanks for having me. Hopefully this is useful.
Definitely. Okay, I'm stopping the recording now.